Okay, so today we will start with projection of solids. Obviously, in the first classes itself, while I was giving the introduction into orthographic projections, we have already seen the projection of solids. In fact, uh, it actually looks easier than planes, and especially when it is, planes inclined to both planes, it is way much easier than planes. So introduction, when I was giving the introduction, so we have already shown what it looks like to draw orthographic projection of solids. So here in the first drawing itself, so we see that if we see from the front here, if we see from the front, if we look from the front, what we will see is this surface. So this is the surface that we will see when we look from the front in this direction, that is. So we will see this surface being projected on this vertical plane. So that is the front view projection. So that is what we have drawn here. So that is the front view projection. Obviously, if you see from top, what you will see is that at a particular distance, at this distance, first of all, you will see this plane, then this plane, and the other side of the plane over here. So what you will see is basically it will look like something like this. So it will be as long as this particular side over here, and we will see the object in this manner. So that is what we will see from the top. So that is what we will see from the top. So this is the front view projection. Of this surface. Okay, so remember that we are only seeing the surface and we are projecting it on the vertical plane. And if we see from above, we will see this surface over here. So this is the surface. Then we will see this surface over here. So that is the surface here. Right, and then we will see the other part of the surface. So that is the top view. And we have obviously seen what the front view will look like. So when we consider the first angle projection, so this particular object is in the first quadrant, right? So here we see, so this is the object here. So this is the object. So if we see from the front, first of all we will see this circular section and the surface here. So this surface, so that is what is projected on the vertical plane. Then the other surface that we will see is this one. So this is the surface that we will see. So this surface will be projected on the vertical plane in this manner. Then when we will see from the front, we will see this surface, but this surface is inclined in nature. So what we will see is that, so this point will be projected up to this point here, right? So this point will be projected up to this point here. So parallel projections. So these lines has to be parallel, right? As we have seen for the inclined planes. So this is basically an inclined plane. So this is projected up to this point, and this entire surface we will see in this manner. So that is the front view. So this is the front view over here. So this is the front view. Now when we see from the top, now this entire section, what we will see is as a plane over here. This one, because these edges we will not see. Alright, so we will see that this entire circular section, it is looking like a rectangular section here. So that is the section here being projected on the horizontal plane. And when we will see from the top, we will also see this surface. So this top surface we will see here. So this is the surface that we will see. Along with this one. Along with this part, that is right. So we will see in this manner. We will, when we look from the top. So this is projected on the horizontal plane here. So it is all about the visualization, right? So imagination. Right? So you have to visualize the object, how it will look from the various angles. Obviously, if you see from this side, what you will see is this upper edge over here, right, and this entire thing as a straight line. So you will see this section here like this. So this point will project here, this point will project here, right? And when you see from this side over here, so you will see this plane. So you will see this plane over here, right? So it will be projected on the profile plane in this manner, and again this inclined plane, so it will be projected straight here, this point straight here, right? And what you will see is this section over here. So I hope you could get the idea of what is orthographic projection of solids. Okay, so mostly we will be confined with the front view and the top view. In certain cases you may be given the left hand side view. So just for the basic understanding and introduction. So the thing is that when you have to draw, so when you will draw the solution, so the front view, obviously, so since it is in the first quadrant, obviously it will be on the top. So it will be on the top. So when you see from the front, when you look from the front, that is, so you will see this surface and this surface. So both of these two surfaces will be projected on the vertical plane. Again, when you see from the top, what you will see that at the distance, particular distance, you will see first of all this surface over here. So this surface over here, so that is being projected on the horizontal plane, and you will see this surface. So that is projected on the horizontal plane. So this is the top view. So the top view is always at the bottom here. And when you have to draw the, if it is asked the left hand side view, so this from what it will look from this side, right, in from this side. So what you will see is this surface. So this surface you will see. So where you will see it will be projected on the profile plane in this manner. So one of the things that you can do to find out the left hand side view is you can draw one 45-degree line. Then you can project from the top view. From the top view you can project horizontal lines to the 45-degree lines in this manner. Okay. So in this manner you can project. Then from the points of intersection again you can project vertically upward. And from the front view you can project horizontally. So just like we did with the planes, right? And then when you find out the points of intersection you can complete the left hand side view. So you can complete the left hand side view. Now here you can draw 45-degree line, or you can also from this point you can also use arc. So you can also use arcs. Okay, so there are two ways to find out the left hand side view if you are asked for. Okay, so front view, this is the front view. So what we are seeing is this surface and this surface in the front view. Then the top view, so what we are seeing is only this surface and this surface. So this surface and this surface over here. So that is the top view. And then you can join from here, you can draw arcs, or you can use the 45-degree line, right? So this is 45, this is 45, right? And you can draw horizontal lines, and then from there you can project. Both of the things are accurate and same thing, right? And from here you draw horizontal projectors, find out the points of intersection, and you draw the left hand side view. So just for a quick understanding of the things, so here we have an object and it is given, so this is the front view, it is given, this is the front view. Okay, obviously the left hand side view will be from that side, all right, and the top view will be from the top here. So if I see from this side, what I will see is, first of all, this, let us draw this surface. So this line I will see first. So I will see this line. Then I will see this line. So I will see that line. Right? Then up to this point, what I will see is this entire curved object as a rectangular projection. So the projection will be rectangular. So the projection will be rectangular. Okay. And of course there is space here, annular space here. It is being cut out here. So we have to mark that by dotted line. Right? And this will be obviously 70 mm or 70 units, whatever it is given. So 70 units. All right. Now let us concentrate on this. So what I will see is the diameter. All right. So I will see in this manner. All right. And this will be the thickness. The thickness will be in the dotted line. And it will continue to the bottom. And it will continue to the bottom here. So that is the front view. So that is the front view. Have we left anything else? So no. So that is the front view. Now again, if we see from the side, what we will see? So we will obviously observe this entire curvature over here. So first of all, let us draw this edge. So this is the edge. Okay. And then there is a straight portion. And then there is a curved portion. Okay, and then there is the annular opening. And then when we will see from this side, so we will see this top over here. So we will see here. So ultimately, and then we will see the thickness of the plate. So that thickness of the plate has to be mentioned. So that will be in dotted line. Okay, and we have to also mention that this is an opening. So that is a dotted line over here. So this is what we will see when we see from the left hand side. So top view and left hand side view. And when we see from the top, what we will see is, so we will see this surface. Obviously this is the surface that we will see. So we will draw that surface. All right, then so here you see, so this particular object has to be shown, so that will be in dotted line. So this will be in dotted line. Again, that other portion will be in dotted line. Right, then the annular spacing, the opening has to be shown, so that is will be in dotted line. That means we cannot see them, but it is there. We have to notify the person observing the drawing that there is an opening there. Okay, and then obviously you will see this entire opening here, and this will be the thickness of the wall. Yes, so this is thickness of the wall. So that is what you will see. Okay, so this is the top view. So am I correct? So you can see, so this is the top view. Okay, so there is a constriction here. So there is a constriction here, so that has to be shown here. Okay, so this is diameter of 30 units inside. So this is 50 units and this is 60 units diameter. Okay, so this is 60 units diameter. So that is the top view. And the front view also, yeah, that part I missed. So this 30 units opening I missed. So other things I have already accounted for. Okay, so here what will happen is the dotted line will be here, not here. Okay, so there will be very complicated objects as well. So just for your understanding, so if I see from the front, so what I will see, first of all, this surface I will see. This is the surface that I will see. So I will draw that surface. Alright, then there are opening here. So again, as in the previous case, alright, so there are, the opening is of this manner. Now let us concentrate on this part. So first of all, I will see this entire surface. So this edge over here, then this entire edge over here, this surface, and then this surface. Okay, so it will be somewhat like this. Okay, and this part in between, and obviously we will see this surface as well, and this opening over here. So there will be an opening here. Then we will see this surface. So we will see this surface, right, and there will be an opening. There will be an opening here. Then we will see this surface as well. Alright, so again there will be this surface. So did I miss anything else? I did not. So it is almost looking exactly what I have drawn. Okay, maybe the positions are, since I have not drawn to scale, the positions are somewhat different. So ultimately that is what we have looking at. So this is the surface. So this is the surface over here. Okay, then this surface. Okay, so this is the surface. Then the entirety, so we will see only this surface over here. Okay, so this surface, so this is the surface that we will see. Okay, and then we will see this part over here and this part and this part. So this surface and the surface over here. So that is the front view. Obviously you can think of how the top view will look. That I leave it to you. So let us just for quick understanding again try some simple geometry. So this, if I try from here, so what will be the front view? So I will see this plane up to this edge over here, up to this edge. Okay, so that is the line over here. Then I will see this part, right? So it goes up and makes a semicircle, comes down, and we end up here. So this part of the surface up to this, alright. So when it becomes perpendicular, from the point when it becomes perpendicular, we cannot see this surface. So up to the point it becomes perpendicular to our angle of view, we can see the surfaces. Alright, so this surface we have drawn. Then we have to draw the opening here. Right, then here you see we will see this surface as well. So this is the surface that we will see. So this surface we will see here. All right, from the front view. So this is the front view. Again, if we see from the top, what we will see, obviously this surface. So let us change the color. So obviously we will see this surface. Okay, so the entire object will be of same length and breadth as the object given. So first of all, here there is the curved surface. So here there is the curved surface. Now what we will see, so we will also observe this part up till it becomes perpendicular. So up till it becomes perpendicular, we will see this surface, and similarly we will also see this surface. So this part, this surface of the surface we will not see. So this part of the surface we will not see because it is perpendicular to our view, angle of view. Yes. So what we will see is, so this is the object here, all right, and you can see that it extends to some I mean if I mean extend this perpendicular line over here, so I will see that it is a little bit extended inwards, right? So some little bit of curvature I will see there, so some amount of curvature will be there, and it will be a straight line. And here I will not observe any edges, all right, because there isn't any. It is a circular, I mean, surface, so I will not observe edges over there. Only this edge I will observe. So this edge is this one, and you can see it is a little bit going into the circular surface. So this part is there, and we observe the top view. So this is the top view, and this is the circular edge of this part over here. Okay, so yeah, so the yeah, okay, then I forgot this one. So this has to be included here as a dotted line. So we have to show that it is, I mean, there is a space. So dash dot dash dot dash dot dash. Okay, so that is a annular space. So that is, this is a space, that means, okay, so it is hollow in there. So that we have to show in the drawing. So that is the space there. Okay, here they have not shown this part. Here they have shown. All right, so this is the view from this side, that is. Okay, so here if you see from this side, obviously up to this edge you will see, because from here then this is perpendicular. So up to this edge you will see. So up to this edge we will see. So this is the edge here. Then we will see that this particular thing goes and meets there. So it will go and meet up to this point. All right, then we will observe this part up to the point it becomes perpendicular here. All right, so we will observe this surface over here. Now this surface you can see, and it goes and meets this circular surface, so it will show in this manner. All right, so there are no edges here, so there are no edges here, so it evenly goes and smoothly meets. I mean there is no intersection of edges in between here. All right, and we will of course see this entire surface. So this surface we will see, this surface we will see, and this surface we will see. So these are the surfaces. All right, so here this part, all right, so this is the part over here, and this surface, so this surface over here. So now we have one object here, simple object again. So if we see from the front, again we will observe up to this point. This surface we will observe first of all. This is the surface that we will see. So this entire surface we will see, so we can draw that. Okay, then what are the things we will see? So we will see this surface as well. So we will see another surface here, and this is the surface. Then we will see this surface as well, up to when it is hidden by this part. All right, so here what we will see is in this manner we will see. So this is the surface that we will see. Then obviously here it is an annular space, so dot dot dot. All right, and here also is an annular space. All right, so that is what we have to mention. So this is the front view. If we see from the top, all right, so yeah, so this, it matches with the one that we have drawn. So again, if we see from the top, now what we will see, first of all we will see that this surface, okay, let us change the color now again. So we will see this surface, all right, and this surface, again this surface over here, and up to this perpendicular point we will observe this surface. So obviously it will be, the length will be same as the front view. All right, so there will be one circular edge, and from there on there is a rectangular section here. Okay, then from here you can see, we will see this part, and up to this point we will observe this one. So from there on we will see the top part. Okay, so that is what we will see, the top part, and it will come and be somewhat like this. Okay, then this will go and meet here. Right, and obviously there will be, so this section will be there. Okay, so that will be the top view. So this is the top view. Alright, so not this line, so this line you can wipe off. Okay, so can you get the feel now? So yeah, it almost matches with what I have done. Okay, so it is all about the visualization. Okay, so you have to visualize the things. So here is another one. So obviously if we draw the front view, we will see this edge. So this is the surface. So this is the surface. So this surface we will see. Then what we will see is this surface. Okay, so we will see this surface up to the height. The height is same, you can see. So up to this height. Again, we will see also this surface. All right, so this is the part here, again up to same height, and up to this point we will see. So this is the front view. So this is the front view. And then when we see from the top, what we will see? So we will see the outer edges. All right, so we will see this entire surface. So let me change the color maybe. So we will see this entire surface. This surface we will see, and this surface we will see, and this surface we will see. So here, corresponding to this one, will be one block of this nature, and here corresponding to this one will be one block of this nature, and the rest. And the rest. So that is the top view. And this is the front view. So is it matching? Yeah. So this is the top view and this is the front view. Obviously, if you see from the I think they made a mistake here somewhere. So okay, no, it is okay. So yeah, this part, this line should not have been there, because you will not see any edges here. Okay, so this part should not have been there. Oh no, sorry. This is obviously from this side. Okay, So from this side, when you see, you will see this edge. Okay, so this is the entirety edge you will see. So this is the edge. Okay, but then you have to mention that about this point, about this also you have to mention. So this is a dotted line over here. Okay, and you will observe this surface. So this is the surface here. Okay, so this is the side view. This is the front view, and this is the top view, and this is the side view. So we have to, so this is one aspect of the problem. You may be given this kind of objects and you have to draw the top view and front view, and if given also side view. So it is and the dimensions will be given obviously, and you have to draw it according to the dimensions given, just like the first example that we saw. So this, right, so obviously and this dimensions here it is given. So this is 15 mm, this is 70 units, all right. So and then radiuses are given, 40 units radius. Okay, so this lobe, so this is a lobe over here, right. So and this is the start, that is the center of this one is 30 units from this edge. Okay, so all of that you have to make out. Then apart from that, all right, we have to for some simple objects we have to first of all visualize the object, and then we have to make the projection drawings. So here a question is given: draw the projection of a triangular prism, base 40 mm side and axis 50 mm long, resting on one of its bases on the HP with the vertical face perpendicular to the HP. Alright, so that means, so let us again first of all start with the concept drawing. So this is the two planes. So we have the triangular prism. Now triangular prism, it is triangle on the basis, and we have, so it is of this nature, right. So I hope you can make out. So it is a triangular prism. So the prism is standing. So here you see with a vertical face perpendicular to the VP. So one of the perpendicular, the face, one of the face is perpendicular to the VP. So it is in this manner, that is. Okay, so it is perpendicular to the VP. So this face and this other two face. So if we then this is the prism. Okay, triangular prism. So it is in front of the VP, alright, and axis of the prism is perpendicular, it is said here. So you see, draw the projections of a triangular prism, base 40 mm, so 40 mm side, so base 40 mm side, so this is 40 mm, these all are 40 mm, and axis is 50 mm long, so it is basically height is 50 mm, alright, and resting on one of its bases, so it is resting on one of its bases on the HP with the vertical face, so this is the vertical face, with a vertical face perpendicular to the vertical plane, right. So it is perpendicular to the vertical plane, so that is what it is seen. So if you now see from, first of all let us, because it is easy to draw the top view, so first let us draw the top view. So I will start with the XY. So this is x and y, so this is x and y. So I will drop one perpendicular, right? And it is not given at what distance the prism is or whatever, it is not given anything. So at a particular distance, whatever is according to my liking, I will take the start. So from there I will mark 40 mm, and there I will draw the equilateral triangle. So basically this is the projection of this face. This face, right? So this face of the prism is being projected on the horizontal plane. So this is the top view. Now how to go about drawing the front view? So from the front, when we will see, what we will see is this edge, this edge of the prism, it is projected onto the vertical plane in this manner. That is the edge here, and this entire surface we will not see this surface. So this edge will be projected here in this manner. So what we will see is basically a rectangle on the vertical plane, and basically it will be the projection of this surface, right, on the outer surface. So what we do, we project this point, right, and from here, so since it is said that it is on the HP, okay, so it is said that it is one of its bases is on the HP. So on the HP is one of the bases. So from there we will draw 50 mm, and we will draw 50 mm. Okay, so this will be 50 mm, and we will get the front view, and this is top view. Okay, so easy. So this is the prism. So this is the prism. So you can see this edge, this surface is perpendicular to the vertical plane. So this surface is perpendicular to the vertical plane. So when we see from top, so we draw this line first, then we draw the projection of this face, okay, of this face. Remember that, not this face. We are not drawing the projection of this face, we are drawing the projection of this top face, because from the top we will only see BCA, not EFD. So that will be small b, c, and small a. So this is the top view, this is the top view projected on the horizontal plane, and then we, from the front, we project the point F, and we get the front view. So we get the front view. Okay, so in the on the front view, what we will see definitely F, which is F dash, and C dash, definitely C, and A and D. All right, so A and D. So here they have mentioned that B dash and E dash is hidden. All right, so this is D dash, and this is A dash. So basically we will see this surface. This is the surface that we will see, and the rest of the prism will be basically hidden. Right, so this is the solution. So similarly we have a pentagonal pyramid. All right, so we have a pentagonal pyramid. So here you see it is resting on its base. So this is the base, So this is the base. So if you see from top, obviously what you will see is, so one of the edge is parallel to the line of intersection, right? So this is the edge, so it is parallel to the line of intersection, and then the rest of the pentagon, right? In fact, we will see only these surfaces we will see, right? So these are the surfaces that we will see, not this surface. Okay, so we have to first mark the point O, right? And this is the top view projection. So O will be projected here, right? And this is the top view projection. So this is the top view projection. So the surfaces, so here B, C, O, similarly A, B, O and E, O, A are the surfaces that we will see from the top. Right? We will not see the base of the pyramid. So this is the top view. Then from there on, we will project the points. Right? So O we will project. So the height of the pyramid will be given. And from there, whatever is the height given, we will first draw the point O. Then we will project the points. Okay, so from here, so we have these two lines. So basically we will see these two surfaces from the front view. So this OAB and OBC are the two surfaces that we will see from the front, right? And we have to mention that there are some hidden surfaces as well, right? So dotted lines. So these surfaces, these three surfaces will be hidden. So we have to mention that they are hidden, right? So that is why this is the front view, what it looks like. So this is the front view projection. So this is the front view projection, and this is the top view, which is beneath the pyramid. Okay, so this is the solution here. Then yeah, as I was saying, so you can draw the side view, right? So here, from here, they have dropped horizontal projectors here they have dropped. So from there, either you can draw the 45-degree line, or you can straight away use parallel lines. Right, you can use parallel lines, or you can use arc. Right, you can use arc. Right. So arc is the best option. I would prefer to use the arc. So using the arc, you first transfer the points up to here. Then obviously there is only one point in the side view over here, and from there you join the points. So here from the side view, if you observe, we will see the plane A, B, O. We will see this plane A, B, O. So that is here A, B, O. So this plane we will see. Then we will see E, O, A. So E, O, A we will see, right? And then this edge will be actually hidden behind this edge. This edge, OC edge, will get hidden behind the OA edge. So we will not see that. and this axis is shown here. This axis is shown here. Okay, so that is the left hand side view of the pentagonal pyramid. Then there is another question here. Draw the projection of a cylinder base 40 mm diameter and axis 50 mm long. So again we start from the concept. Alright, cylinder base 40 mm diameter, base is 40 mm diameter. Right, and it is axis is 50 mm long, so it is 50 mm long. So it is standing in front of the plane in this manner. And we also have a cone. So we have a cone in there. So obviously if you see from top, what I will see, so this is xy, this is xy. I will see the top circular surface, right? And then I will project it up. And when I see from the front, what I will see is, I will see a rectangular projection. So this is the front view. So easy. All right. Now in case of the cone, if it is the cone, so in case of the cone, so okay, so this is the object, so this is the cylinder, all right, in front. So this is the front view and this is the top view. This, I mean, this is the top view projection and this is the front view projection. So this is the top view and this is the front view. Of the cylinder. So this is the solution. All right, and if you consider only the cone now, if you consider the cone, so obviously when you see from top, you will see the surface of the cone. So you will see the center. You have to mark the center, and then you have to draw the projectors. All right, so this will not go up, definitely not. Sorry, so this will not go up. This will go up 50 mm. All right, so this will go up 50 mm, and from this point we will join here and we will join here. So this is the cone. So this is the front view for a front view projection, and this is the top view projection. Okay, so this is the solution here. So this is the cone. All right, then a cube of 50 mm long edge is resting on the horizontal plane. It is resting on the horizontal plane and its vertical faces are equally inclined to the VP. Okay, so we have a cube and the cube is resting on the horizontal plane and its vertical faces are equally inclined to the this vertical plane. So we have this cube. Right, so the cube is in front of the vertical plane. So easy to, and the edges of the cube is 50 mm. So this is the cube. All right, so if you see from, first of all, if you see from top, what I will see, so this is the surface that I will see. So this is the surface. All right, so A, D, C, B. So this is the surface that I will see. So then what I will do, I will project the projectors here, right? So I will project the projectors, and so this is 50 mm, and I will see these two surfaces. One is GFEH and the other is FGBC. So that plane is hidden in here, you cannot see that. So that plane is hidden in here. So FGBC is one plane. So this is FGBC, and this is BFEH. So this is BFEH. So this plane and this plane. All right, and from the top you will see this surface ABCD. So ABCD. Okay, so that is the solution. So the other parts we will continue in the next class. So I hope you have understood. So these are all the planes. So up till now we have discussed solids where the axis is mostly perpendicular to the horizontal plane. Okay, in the next class we will discuss and is perpendicular to the horizontal plane. Yeah, axis is perpendicular to the horizontal plane. In the next class we will discuss in the other parts, that is when it is perpendicular to the vertical plane and when it is inclined. Okay, so in the next class, that is in the next Thursday, that is. Okay, so this is the projection of solids, and we will, it is already 9, so we will stop here.